Okay, so we're going to do some help here for 2-1. I'm going to start by just looking at question number 8, and I think we'll do question 12 as well. So question number 8 says we've got a 1580 kilogram car. So that's a mass because it's in kilograms. It's got a speed of 15 meters per second. Now, we want to stop the car in a distance of 50 meters or less. So we want to know how much force do we have to apply to do that. Now it's going to be applied through braking and through friction, but we want to just know how much do we have to apply there. And so if we're thinking about this question, we have a few things. We know that mass is 1580 kilograms, and we know that force, which is what we're looking for, is how much force, is equal to mass times acceleration. Well, since we have the mass, we just need the acceleration. Well, the acceleration can either be given to us, or we can be given information that will help us understand it. Specifically, we know that there's an initial velocity of the car, which is the 15 meters per second that we're currently traveling. But we want to get that velocity down to 0 meters per second by the time we're done accelerating. The acceleration is not stated, but we know that it's going to happen over a distance of 50 meters. Okay? So we can go back to our kinematics to help find things like acceleration. Oftentimes when we work with these force problems, we're going to have to go to the kinematics. And so if we do that, we get v squared equals v naught squared plus 2a delta x. V squared being 0 equals 15 squared plus 2 times a times 50. So if we square the 15 and we subtract it over, we get negative 225 equals 100a. We divide by 100. And we get that a must be negative 2.25 meters per second squared. Now that we know that's a negative 2.25 meters per second squared, we can calculate F equals ma using our mass, 1580, times our acceleration of negative 2.25. So grab my calculator. I think I find it. There it is. Turn it on. We've got our 1580 times a negative 2.25, and we get a negative 3555. And you notice the book, or the answer here on OneNote has 3560. First, it says it's positive. Well, that's because they're talking about the magnitude. So you can see the word magnitude in the instructions. It says, what is the magnitude of the net force? Well, magnitude is going to come out positive. That's why it's positive. Now we know it's negative in that it's slowing the car down, so we should expect it to be negative, but magnitude alone will be positive. And then they round to 3 sig figs, which would make it the 3560. So we can say that the force is roughly 3560 newtons. Okay, so that's question number 8. Let's start over and find question number 12. Okay. So here in question number 12, let's pull that up. It says only 2 forces acting on an object with a mass of 3 kilograms as in the drawing. That's this drawing over here to the right. And we're going to be asked to find the magnitude and direction relative to the x-axis of the acceleration of the object. How much is it accelerating under these forces, and which way is it going to accelerate? What we have to understand about this problem is that it comes down over and over again to redrawing these oh my goodness, what's the word? Vectors, thank you. Oh my goodness. So we have a 40 Newton vector, and instead of doing them both from the same location, I like to do it what's called tip to tail. So the tip of one arrow becomes the tail of the next arrow. And then I'm going to have my 60 Newton force there. And what we really want to do whenever we're adding vectors is go from the beginning to the end all in one constant motion. And so this is what we're really being asked to find, is that red direction there. Now, in order to do that, we're going to have to think about this as a bigger right triangle. What we do know is that this angle here is 45 degrees. We need to figure out the x component here and the y component here of the 60 Newton force. Well, we know that the x component is always the hypotenuse, 60, times the cosine of the angle. and that the y value, or the y component, is always 60, or the hypotenuse, times the sine of the angle. Okay, so we have those two values. We can throw them in the calculator. I'm not going to bore you with the details of the calculator. These both come out to 42.4 newtons. When we no longer have this piece here, that vector's now been broken up into its two parts. I'm going to try to do this a little bit of justice here. We're going to draw a new right triangle. Let's undo that. Thank you. And we're going to call this length here the combination of 40 and 42.4, or 82.4 newtons. Now the y component is just the y component from our 60 newton force, which was 42.4 newtons. All right, I think we're going to expand this up a little bit. All right, now what we want to do is try to figure out what's the angle and what's the, this is essentially our F in the x direction, this is F in the y direction. We want to know what the force is and what theta is. Well, to find the net force, we just need to use Pythagorean's theorem. And so we grab our calculator. Let's see if I can drag that over a little bit. Nope, not going to let me. Okay, come on, try there. Okay, so we're going to take the square root of 82.4 squared plus 42.4 squared. That's Pythagorean's theorem solved out. We get 92.7. I'm going to say this is 92.7 newtons. Okay. To find the angle, we're going to set up a tangent. The tangent of theta is the opposite, which would be 42.4, over the adjacent 82.4. We'll use our calculator for that. Let's bring this back this way. We're going to want to take a tan inverse in order to finish solving it, so I'll just jump to a second tan of the 42.4 divided by 82.4, and we get 27.2. So our theta is 27.2 degrees above the x-axis. If you think of this being the x-axis, you can see that we're rotated above the x-axis. So I know that much is true. The issue that we're going to have, though, is the 92.7 newtons that we got as our answer, it doesn't match the 30.9 meters per second squared. We can see the 27.2 right there, kind of blinking at it, but we can't find the 30.9 until we remember we're being asked for the acceleration of the object. We were given the forces. Well, because the object has a mass of 3 kilograms, kind of blinking at it right there, 3 kilograms, I should be able to take the force, which should be mass times acceleration, the force being 92.7 equals a mass of 3 times my acceleration. So if I divide by 3, I grab my calculator, and 92.7 divided by 3, I get 30.9. So this tells me I'm going to accelerate at 30.9 meters per second squared at 27.2 degrees above positive x-axis. All right. This whole assignment, so much of it is about breaking force vectors into their parts and then understanding we can always go back to F equals ma at the end and back and forth. But hopefully that's enough to help get you through the assignment. Let me know what you need, and we'll see you in class.